Hey guys, welcome to the second part of a scaling video. In the previous video, we learned about scaling, types of scaling, and the difference between vertical and horizontal scaling. And if you missed the video, please go back and watch that. The link is given in the description. And in this video, we'll try to understand how can we use horizontal scaling to scale our servers, because you want to make sure that how you want to add those server in a very fast and very quick way into the server pool of the server at the time of load. And if you are getting millions of users on your website, so you need to store all those data, so you need to make sure that how can you leverage a scaling thing to add more databases or faster database. And at the same time, if you're getting more users, you want to make sure that your servers are performing well, your application is performing well, so they can serve faster data, and that is possible through cache. And at the same time, when your subscribers are actually fetching more and more data, it's going to be a lot of processing behind the scene onto the server. So you want to make sure that your servers are performing the task while users are able to access your website with no problem, and that is achieved by asynchronousness. So we'll discuss each topic one by one. Let's move on to the first topic, server cloning. So let's talk about how you can use servers cloning for achieving scalability. So this is a typical infrastructure for any scalable public facing websites. You have application server. There I have 5 application servers and 1 caching server to store sessions and user info. And we have 1 load balancer. So the job of load balancer is to distribute the load among all those servers, including caching server. So a user can get all the information from the code base. So as an example, let's user as a you, if you're submitting same request 100 times, it's not necessary that all the request is actually being responded from one server. It may come from any other server. A1, first request may be served by AS1, second request may be served by AS4, third request again AS1, fourth again as AS5. So, and every time you should get same results. It should be idempotent for getting anything. And now that is only possible when you have same code base in all application servers. And for say if something goes wrong and you get out of one server, AS3 is dead, and you want to add one more server, or because of load you want to add AS6, what you need to do in that case, you need to use the cloning. And the cloning is to have one server which is identical to our basic code base, and you store in your infrastructure. Whenever you need to add additional server into that, you just get the clone out of it and then deploy all the latest code into that new server, and you deploy into your network. That's how you achieve that. When you need in future, if you need one more server, you just do the same thing and add that new server. So this is how you add or delete a new server and make sure that your server is scaling and handling all the load based on the need. Cool. Now we'll move on to the next topic about database. Now you're able to handle your servers, and yeah, as users are keep on growing, you are no fear to handle all those users. And later on you notice that your server is again broke down, your application is broken. Why? Because database, your MySQL. So why it happened? Because your job is to make sure that you available all the users their data on time, on fast, but it's down. What you can do to achieve that your database also is scalable at the same time? There are 2 options. What you can do is you can have same database, MySQL or SQL Server, and to maintain the data when data is growing rapidly, you can hire a bunch of database administrator who are maintaining your data to make sure that your data is fast enough to the user. They'll start coming and they say, I'm getting more and more data in our database, so let's add more storage. And you have more storage capacity, you keep on adding data, but you start experiencing some slowdown. They say, let's add more memory, some more CPUs to make sure that data is faster, the server is able to handle those load. And then again, data is growing, they'll ask, let's talk about sharding, distribute data in different servers, different tables, talk about normalization, and blah blah blah, more things. And all options are expensive, it's not cheap. And you see that, it's getting expensive and expensive. It's very expensive. So in my case, I feel option two is better option. And what this option is, you start denormalizing, start from beginning. And the most expensive process for any database operation is join. So try to move that join out of the database level and put that join onto the application level. Let that application handle the load, not the database. Or you can do like, NoSQL database like MongoDB, CouchDB. Those options are way faster and doesn't store much data. It doesn't take much more CPU than standard database like MySQL or SQL Server or Oracle. And now you have no fear to store the data and you keep on adding, but there is a catch. The more data you start adding, the more data is being added into your database, and you need to make sure that your customer are getting the data on time very fast. For that, you need to introduce cache. So let's talk about cache. Why cache is so important. Cache means in-memory caching distributed system like Memcache or Redis. And cache lives into the RAM, and RAM is super fast, so the database access is lightning fast as well. Cache lives between application server and between of the application server and the database server. So you don't have to go to database to fetch the data. You always store the data in middle of that, so application can fetch right from the cache and then serve to the user. And in the cache, we store the data as a key value pair, and there are two approaches for that. The first one is cached database query. So what you do, you actually store the query results in memory, and you actually hash the query as a key. And the next time when you check if query is present in memory, you just read from the cache and serve to the user. If it is not, then you go to the database, but it has some issues. And you can easily guess, like expiration, what you do when your if your cache is getting full and you want to add more and more cache, how will you expire that cache from your cache? The queries from the cache, I should say a key value from the cache. It isn't an expensive task. And second issue is stale data. So for say if you update any row in database for some reason, your cached data is not updated. So when user is being served, it will serve as stale data. So for that, there is another option, that is cached object. What you do, this is the most preferred pattern, and you actually cache the whole object in memory rather than database. So just like in programming, you have an object, you instantiate an object, and that object has all the properties. Same way, you just store all the object in the database, and it will act as a database, kind of in cache. So whenever you request, you just go there, fetch the whole object, and serve to the user or whatever you want. So as an example, you use this user sessions. You always store the user session there. Your fully rendered blog is there. Whenever you request another page or new article, everything is stored as an object into the database. You just load everything right away from there. And any activity stream like Twitter, all the tweets are lightning fast available to the user. It happened all because of cache, and because the whole pattern, the whole object caching thing help us to do asynchronism. What you do, so whenever user requests something and there is a expensive task running behind the scene, and user will not experience anything, so all the requests will go into queuing system, MSMQ or RabbitMQ, and they start processing one by one, and user can do anything on the application, will not experience any delay because of those heavy duty done by server. And it's kind of running parallel thing behind the scene, and user will serve when the task is done. So this is what we learned today. How can you achieve server cloning and achieve the server scalability. We add database like NoSQL database, put all the joins thing to the application to help database to do fast, and serve users faster. You can use cache, and same time use asynchronousness to do heavy lifting behind the scene.
So this is what was summarized for today's chapter, this video. We'll talk next in the coming video, so stay tuned. If you like the video, please like it. If you have any comment, it's kind of beginning of my video series, so you can add that comment into the comment section. Thank you very much. See you next time.